All right, let's start with the easy one, right? So identify the type of conic. If you look at this, your A is 9, your C is -4. So this makes this what? A hyperbola, right? If the product is negative, then it's a hyperbola. Second one, and you can actually use that process for this one. If you look at A is 4, C is 3, that would have a positive product. They're not the same, which means that this answer should be an ellipse. So when you get to the end, even though it's rotated, you should know what kind of shape it is. All right, so let's start with theta. So my A was 4, my B is square root 3, and my C is 3. So the cotangent of theta, or 2 theta, sorry, would equal A minus C over B. So 4 minus 3 over the square root of 3, which is 1 over root 3. And then we're going to look at the tangent, so we're going to flip it. So the tangent of 2 theta is root 3. And then if you keep in mind your unit circle, you should know that tangent is root 3 at pi over 3. So 2 theta equals pi over 3, and theta would equal pi over 6. So that's the first part. That's the first opportunity to get some points. So this question's worth 20 points on your test. That's 5 right there. Then you want to get the x and the y. And I said it yesterday, but I'll remind you that I will give you the equations for the x and the y. So x equals x prime times the cosine of theta minus y prime times the sine of theta. And y equals x prime times the sine of theta plus y prime times the cosine of theta. And we know theta now is pi over 6. So x prime times the cosine at pi over 6 minus y prime times the sine at pi over 6. You should also know at pi over 6 that your point is root 3 over 2 and 1/2. So do that carefully or everything here on out is wrong, right? So this would be x prime times root 3 over 2 minus y prime times 1/2. Or root 3 x prime minus y prime all over 2. And then your y is x prime times the sine of pi over 6 plus y prime times the cosine at pi over 6. The sine is the y coordinate, so this is 1/2. The cosine is the x coordinate, so this is root 3 over 2. And I get x prime plus root 3 y prime all over 2, and that's my y. That'll get you another 5 points. Then I have to take those and plug them in to my original equation. So I'm going to get 4 times x squared. I'm going to leave out the primes for now, but you have to remember to put them back at the end. Plus root 3xy, root 3x minus y over 2, x plus root 3y over 2, plus 3y squared, x plus root 3y over 2 squared. And I'm going to bump the 10 to the other side because it's going to go there eventually anyways. With me so far? Okay, then this is that second algebra skill that we talked about that you could use to help you speed the process up. So if it is a squared trinomial, then I can use the shortcut of, so the 4 is still going to be on the front, of squaring the first term, which would be 3x squared, squaring the last term, which would be a positive y squared, and then doubling the product of the two terms. So the product would be negative root 3xy, double it, and it's negative 2 times root 3xy plus that y squared all over 4. Then I go to the next one. So this is plus root 3. This time those terms are not the exact opposites or squared, so you got to actually FOIL it out. So this would be root 3x squared. This would be 3xy. This would be negative xy, and this would be negative root 3y squared. I can combine these like terms, so I end up with root 3 times root 3x squared plus 2xy minus root 3y squared all over 4. And then I go to the last one, And again, it's a trinomial or a binomial squared, so I can use the shortcut. X squared is the first term. 3y squared, a positive 3y squared is the last term. Multiply these together and duplicate it. It's positive 2 root 3xy all over 4 equals 10. Don't forget your constant on the other side. With me so far? All right, now all your denominators are 4, so I can multiply everything by 4 and eliminate them. It's gone from here, from here, from here, and this 10 becomes 40. Then I want to distribute the constant that's on the front of each of these parentheses. So from my first one, I'd get 4 times each of these, so 12x squared minus 8 root 3xy plus 4y squared. And then you go to the next one. Root 3 times root 3 means that's a positive 3x squared plus 2 root 3xy minus 3y squared. And then I go to the last one. Plus 3x squared plus 6 root 3xy plus 9y squared equals 40. Now I'm going to combine my like terms, but the first ones I'm going to check are the xy terms because this is where I can check to see if I've done it correctly. If I've done it correctly, my xy terms will cancel out. If they don't, I know I made a mistake and I need to correct it now. So negative 8 root 3 plus 2 root 3 is negative 6 root 3, and then negative 6 root 3 plus 6 root 3 is 0. So these have canceled out, so at least I know I've done that part right. Then I'm going to go to my x squared. It's 12x squared plus 3x squared, that's 15x squared, plus 3x squared, that's 18x squared. Then I'm going to look at my y squared, 4y squared minus 3y squared, that's 1y squared, plus 9y squared, that's 10y squared, equals 40. I've got to divide everything by 40, and I'm going to bring back in my primes. So I'd get 18x prime squared over 40 plus, and actually let me reduce that right at 1 minute. This would be 9x prime squared over 20 plus y prime squared over 4 equals 1. This is my ellipse in standard form. Questions on that one? That'll give you another 5 points. So from there, I'd have to figure out what kind of ellipse it is, where my center is, all that good stuff. Before I do any of that though, this is the first time that we've seen a number at the top when we are in standard form. So we've seen it before where there's a number at the bottom and you have to bring it to the top, but this is the reverse of that. If there's a number at the top like that, that actually becomes the denominator on the 20. So before you can look at that and determine which is larger, you have to move that 9. So because the 4 is bigger than 20 over 9, the 4 is your a squared, making a 2. The b squared is 20 over 9, which makes b square root of 20 over 9, or 2 root 5 over 3. Because the a is under the y, I know this is a vertical ellipse. And there's no h or k, so I know my center is 0, 0. So then I go to my graph. So my initial xy looks like this. My theta is pi over 6, which is about here. That's going to be my x prime. This is going to be my y prime. And then my ellipse, my center would go here. It's vertical, so I'm going up and down 2. And then the horizontal is the 2 root 5 over 3. We have to approximate that. So it's probably easier to approximate it from the square root of 20 over 9. I know 20 over 9 is like a little bit bigger than 2, right? So it's 2 and something, which means when I square root it, it's 2 and 2 nines. But that means when I square root it, it's in between 1 and 2. So let's just say it's 1.4 because it's closer to 1 than it is to 4. then that means my B goes out that far. And then I connect those to make my rotated ellipse. Questions on the rotation? All right, so A is 0, B is 1, C is 0. So this would be 0 over 1, which is 0. That means the tangent of 2 theta would be undefined. Tangent is undefined at pi over 2, so 2 theta would equal pi over 2, and theta would equal pi over 4. That's the angle, right? Then x would equal x prime times the cosine of pi over 4 minus y prime times the sine of pi over 4. Pi over 4 is root 2 over 2 and root 2 over 2. So this is root 2 x prime minus root 2 y prime all over 2. And the y is x prime sine pi over 4 plus y prime cosine pi over 4. So this is root 2 x prime plus root 2 y prime all over 2. So there's your x and there's your y. Then you got to plug it in. So x, I'm going to leave off the primes for now. I'm going to make them come back at the end though. So I plugged it in. The first one is that difference of 2 squares shortcut. So I square the first term, that's 2x, and I square the last term, put a minus between them, that's 2y, or 2x squared and 2y squared, and that would go over 4 plus root 2x minus root 2y over 2 minus, and actually what you could do before you even do that is multiply everything. You'd have to multiply it by 4 if you want to get rid of the denominators though. So this could be 2 and then root 2x plus root 2y over 2 plus 5 equals 0. So the only one you had to multiply out was that first one. And then you can distribute here. So the only one that needs to be distributed is this. So I get 2x squared minus 2y squared over 4 plus root 2x minus root 2y over 2 minus 2 root 2x minus 2 root 2y over 2. I'm going to bump the 5 to the other side. So you can choose to actually multiply everything by 4, get rid of the denominators, or that first one, all of those numbers are divisible by 2. So you can do that and simplify it. And then multiply everything by 2 to get rid of your denominators, and this becomes negative 10. So now I've got x squared minus y squared plus root 2x minus root 2y minus 2 root 2x minus 2 root 2y equals negative 10. Then I would check my xy values. From this point on, you actually, so if you end up to here with your rotation of a conic and you've got a squared and a non-squared, you have to complete the square on these. Okay, so the 2 examples that we did, the center was at 0, 0, so there's no complete the square. But if you look at this, you'd have to complete the square here. So I'd have to group together the x squareds and the root 2x and the negative 2 root 2x. And then I'd have to group together the y, negative y squared, negative root 2y, negative 2 root 2y. I'd have to combine my like terms here. I'd have to find the center term, divide it by 2, and it's going to have a root on that one. Divide it by 2, square it, then it gets rid of the root, and then add that to the other side. Okay? So the process, I'm not going to make you do complete the square with a root, but make sure you know how to complete the square once it's to that point. So your 9.1 and 9.3 test, actually has 10 problems. Two circles, 2 parabolas, 2 ellipses, 2 hyperbolas, and then 2 from the classification and the rotation of the conic, okay? Their point values range, and I put it on there, but they range from like 5 to the biggest one is 20, which is that rotation one. There's no calculators, so just be really careful with your math. So it goes back to 9-1, which was circles and parabolas. If you remember, the standard form of your circle was x minus h squared plus y minus k squared equals r squared, where your hk is your center and r is your radius. So you'll see 2 different types of problems with these. One in which you're going to be asked to complete the square to find the equation and then find the information from it. And then one in which you'll be given information like the center and a point. And you have to find the equation. And if you remember, there's 2 ways to do that. One is take the center and the point, plug it in, solve for r. The other is find the distance between the center and the point. That's your r. You just got to make sure that when you plug it back in, you square it. Questions on circles. So I'll give you back, I have one more opportunity for the makeups to happen tomorrow morning, and I'll give you back your quizzes tomorrow so that you can look over those, because those were 9-1 and 9-2. Okay, then came the standard form of a parabola, and there were 2 kinds. So the horizontal parabolas were ones in which they point to the right or point to the left. This is a y squared. So if it's a y squared with a positive p, then my parabola points to the right. If it's a y squared with a negative p, then my parabola points to the left. And the standard form for either of those is y minus k squared equals 4p times x minus h. And p is the distance in both of these. Distance from both the vertex to the focus and the vertex to the directrix. For a vertical parabola, if it's an x squared and it's a positive p, it's going to open upward. If it's an x squared and a negative p, it's going to open downward. And the equation for that is x minus h squared equals 4py minus k. So the h is always with the x, the k is always with the y. If it's horizontal, the y is squared. If it's vertical, the x is squared. And the p term, whatever that 4p is, always goes on the side that is not squared. So the squared term is always by itself. From a graph or from information, you're going to have to find the vertex, the focus, and the directrix. So remember, the vertex and the focus are both points. The directrix is an equation because it's a line. So it's either an x equals or a y equals. Let's just say you were to draw a vertical parabola. This would obviously be my vertex. This would be my focus. This would be my directrix, which would be, in this case, a y equals equation. So that would be like a y equals negative 1. And then remember that the distance between the vertex and the focus and the vertex and the directrix is p. Whether it's vertical or it's horizontal, all that information is the same. So if it was horizontal, let's say it's here. This time it's an x equals. And again, distance from vertex to focus and vertex to directrix are the same. So you'll see two questions on parabolas, one in which you're given information about the parabola and it wants you to give it the equation, the other where you're given the equation and you've got to get the information out of it to either graph it or identify the center, the vertex, the focus, and the directrix. Questions on parabolas. Okay, 9.2 is ellipses. So the standard form of ellipse, again, there's two different types of ellipses. The horizontal means that it is wider than it is tall. So this is an x minus h squared over a squared plus y minus k squared over b squared. And the order doesn't matter because it's a plus. What is important is that the a is larger. So if the larger number's under the x, it makes it horizontal. If the larger number's under the y, it makes it vertical. So the order doesn't matter. X can still come first. The difference will be that the smaller number will be under that x and the bigger number will be under the y. So if it's a horizontal ellipse, let's say your center's at 0, 0, you're going to count to the right your A, you're going to count to the left your A, you're going to count up your B, you're going to cut down your B. These would be your vertices, these would be your co-vertices. You would connect them, and then if it had asked for it, the focus would be somewhere inside on the larger axis, C distance away from your center. So A is distance from center to vertex. B is distance from center to co-vertex. C is distance from center to focus. And A and C are always going to be on the major axis, and B is going to be on the minor axis. The relationship between A squared and B squared and C squared with an ellipse is that C squared equals A squared minus B squared. So that flips for hyperbola. You've got to be able to find your vertices, your co-vertices, your foci, and your eccentricity. So A is get to the vertices, B get to the co-vertices, C get to the foci, and remember eccentricity is C over A. And for an ellipse, it has to be between 0 and 1. The closer it is to 0, the rounder your ellipse is. The closer it is to 1, the flatter your ellipse is. The other types of information that you can get to help you with this kind of stuff is the length of the minor or the major. So if it said the length of the major axis, that is 2A, and the length of the minor axis is 2B. So it usually will give you two pieces of information. You've got to go from there. Okay, then came the hyperbolas and the rotations. So standard form of a hyperbola, so if it's a horizontal hyperbola, then that means that my branches are facing out. And this is an x minus h squared over a squared minus y minus k squared over b squared. equals 1. This time order matters because A is the first term or first denominator. For vertical, this means your branches are pointing up and down, which means y comes first. Y minus k squared over a squared minus x minus h squared over b squared equals 1. This time the first term would be y squared. It's always positive first. The A, the B, the C are the same, so this is center to vertex, this is center to co-vertex, this is center to foci. A squared and plus B squared is now what you use for hyperbola. So it's the opposite of the standard form sign. For an ellipse, the standard form is plus, and the C squared is A squared minus B squared. For the hyperbola, the standard form is minus, and the C squared equals A squared plus B squared. So you're going to have to find the vertices, the co-vertices, the foci. This time they have asymptotes. So with a horizontal, it's y equals k plus and minus b over a for horizontal, x minus h. And for vertical, it's y equals k plus and minus a over b times x minus h. So for a hyperbola, let's just say, for example, that this one centers at 0, 0. If it's horizontal, you're going to count right and left your A. That gives you your vertices. You're going to count up and down your B, which does not have to be smaller. That gives you your co-vertices. You're going to draw yourself a little box. You're going to draw your asymptotes through the corners of that box. If it's horizontal, they're going to the right and left as wide as possible without touching those asymptotes. If it was vertical, it'd go top and bottom. And then your C this time is going to be inside your branches, and that's your foci. So it is C distance away, because the C has to be bigger than A, which leads to eccentricity. This is the same formula, but this time it has to be bigger than 1, because C can't be smaller than 1. And the bigger the number, the flatter the branch. The smaller the number, the narrower the branch. So also 2 questions on hyperbolas, one in which you're given the information, you've got to get the equation, one in which you're given the equation not in standard form, you got to put it in standard form. So you're definitely going to see complete the square more than once, and you're going to see complete the square sometimes with the variable at the front being just x squared or y squared, and definitely something where there's a number at the front that you've got to factor out. So make sure that you are comfortable with all that stuff. Don't spend too much time figuring it out. You won't finish. Questions on that? Okay, and the last part is where we started the day. So we're classifying the conic. There is a question on that. It's only 5 points, but there is a question on that. The good news is super easy. The bad news is that there's no partial credit. It's either all or nothing, right? So if A equals C, what kind of conic is it? Circle. If A times C is 0, parabola, that means that one of them is missing, right? So you're going to only have one squared term. That should make sense. If their product is positive, but they are not the same, then it's an ellipse. And if their product is negative, then it's a hyperbola. And then you get the rotation of the conic. So remember, you need to know that the cotangent of 2 theta equals A minus C over B. You need to know the first quadrant of your unit circle, the points and the tangents. I probably wouldn't spend time drawing all of it out because you're only going to need one angle. Just make sure you know all those angles. And then I will give you the x and y here. So x equals x prime cosine theta minus y prime sine theta. And y equals x prime sine theta plus y prime cosine theta. You've just got to know what to do with it after that point. You'll get 5 points from giving me the angle. You'll get 5 points from giving me the x and y. Then you're going to plug the x and y back into the original equation, simplify it, rotate the axis, and graph it, and that'll be worth the remaining 10 points. Questions overall on anything for your test? All right, your review is posted, okay? I would work on it tonight so you can come in with questions tomorrow instead of cramming it in the night before.